Welcome all to lecture 15 of this course Subsurface Exploration, Introduction and Technique Involves. So far we have discussed like different phases of investigation, why investigations are required, what are the phases of different phases of investigation. Then when we go for detailed investigation, what are the classification of investigation. Then we move to module 2 where we had discussed about geotechnical investigation. So, different kind of geotechnical investigations, what are the methods, how you do the field exploration, how you interpret the results, that we had discussed in module 2. Then in module 3 we had discussed about geophysical investigation techniques, starting with seismic reflection survey to more advanced electrical resistivity, gravity measurements based exploration, so on and so forth. And then at every stage we try to solve some numerical problem, so that we can understand based on maybe from very simple to complex measurements, how we will be able to understand the different kinds of material available beneath the surface, as well as understanding the strength characteristics of the material. So today we are going to start module 4, that is on offshore investigation. So far we have discussed about all the methods particularly related to onshore or the structure which are going to be constructed on actual land masses. But we can see nowadays, we are hearing in the newspapers also, and in a lot of technical reports, like because of land constraints in many of the location, because of contaminated lands, because of considerably large requirements from a particular landmass or proposed site is required. Most of the time, whenever we are going for any specific kind of structures or maybe for mega structures, we are going nowadays on offshore. So offshore is particularly when you are going away from the landmass into the ocean. Depending upon the depth, depending upon the distance from the coastal line, the choice of the foundation, the kind of structure we call, can be categorized further into different categories. So overall it is called as offshore structures. So offshore structure can be for different kind of purposes, which we are going to discuss today, and depending upon the choice of the structure, depending upon the requirement why we are going for offshore, the requirement for the particular investigation technique may change from one to other. So introduction to offshore investigation or offshore environment. Earth, as we know, it's very dynamic in nature, though from the space it looks very stable, but if you start understanding the various processes happening across the earth along with the altitude also, you can see the magnetic poles or the magnetic field across the earth, which keeps on shifting every several thousands of years. So present configuration of magnetic north and magnetic south pole may or may not remain same after several thousand years from today, and which was not there even several thousand years prior to today. So this is like about a magnetic pole which is happening along the surface and everywhere along the earth. Starting with that, if you are going deeper into the earth, with remarkable work particularly done by German meteorologist Alfred Wegener in 1912, he highlighted, based on the collected evidences, like the entire land mass of the earth were in some particular geological time attached towards each other or attached into a single land mass. As per the continental drift theory, it was around 200 million years. Why I am telling, like, though we are considering it's very stable, but lot of processes are happening. As a result of those processes, different characteristics of the exploration site is governing its strength characteristic, it's governing its deposition characteristics, its weathering characteristic, and so on and so forth, will be responsible why we should go for particular exploration, whether it is onshore, whether it is offshore. So starting with 200 million years ago, the entire land mass, like now we are seeing, like somewhere Australia is there, somewhere Africa is there, somewhere India is there, and America is there, but around 200 million years ago, entire land mass was one, which is called as Pangea, which in German is known as all earth. Later, around 130 million years ago, MYE is million years ago, This is how generally we refer to any time scale in geological time. So the entire Pangaea was divided further into two land masses. The one is called as Laurasia, other one was called as Gondwana lands, which further broke down into several smaller continents or major plates, minor plates. For detail of that you can understand maybe from any geological book or maybe seismology book. Present configuration, whatever we see, like where India is there, Africa is there, Australia is there, America is there, South America is there, it is as a result of the various processes which are happening at various depths, and even the impact of temporal changes, spatial changes happening along the earth's surface, and even other governing processes. So whatever present configuration we are seeing, it is as a result of continuous process which has happened in last approximately 60 million years. So even the Himalayas, when we talk about, we assess the age of the Himalayas close to 50 to 52 million years, since the Indian plate and Eurasian plate come in contact with each other, as a result of which, as a result of this collision, Himalayas kept on building. Maybe around 50-52 million years ago that process had started, and so far, so earlier it was like very leveled surface, and because of this collision it started rising, and now we can see Mount Everest, which is the highest peak in the Himalayan range, as a result of this collision, as well as we also witnessed lot of earthquakes happening all along the Himalayan boundaries. So same way, this is about the process happening towards landmass getting converted into hilly terrains or maybe hills. On the other hand, you are having oceans, so some processes are happening along the oceans also, which is governing the seabed characteristic, which is governing different topographical features which are developing along the ocean surface also. That is more important to understand considering the topic of offshore investigation or offshore structures into consideration. So referring to continental drift theory, which talks about like because of if you understand like different kinds of layers which are available along the earth, starting from the crust, that is the uppermost layer, to the core, which, and each of these layers like crust, mantle, core, each are available and with different physical and chemical properties, as well as the physical phase in which it is existing. Some are in solid, some are in molten state, some are in more viscous, some are less viscous, as a result of which, in addition to that, we are having very significantly higher temperature as you go deeper and deeper depth. So as a result of which temperature variation in this viscous material, particularly the mantle, there will be a convection current. So at the top surface of the mantle, the temperature will be relatively lesser. As a result, the material becomes cooler and cooler and heavier, and start settling to deeper depth. Once it reaches deeper depth, again the temperature will be higher, material starts melting, it becomes lighter, and again it will come to the surface. So as a result of this continuous process of heating, cooling, what it does, it actually exerts some kind of actually generates convection current, which induces some kind of push along the base of the crust medium or the topmost layer, as a result of which the continental drift theory says, like as a result of this convection current, there is continuous movement of different plates, whatever we see, Indian plate, American plate, and so on, and depending upon the governing forces under each plate, and if the plate is in contact with other plate, then considering the geological age of the other plate, considering the thickness of the other age, considering the strength characteristic of the other plate, and other processes which are governing the movement of this plate, at some portion you may find plates are moving towards each other, some location plates are moving away from each other, sometimes the plates are moving relatively with respect to each other. So as a result of this continuous process, the thickness of the crust, like wherever it is moving towards each other, you can see like there will be building up of mountains. So the thickness of at that particular location keeps on increasing, and other location where you have ocean, the thickness of the crust will be relatively lesser. On an average, it has been observed that along continents or in continents, the average thickness of the crust is of the order of 80 to 90 kilometers. So 80 to 90 kilometer thickness of topmost layer has been observed along the continents. Similarly, along the oceans, we can see the average thickness of the crustal medium is 8 to 10 kilometers. Now, this is happening all across the globe. So, if it is not possible like everywhere the plates, the two continental plate or oceanic plates or ocean continental plates are moving towards each other or are moving away from each other. As I highlighted earlier, there are a lot of processes which are governing or which are responsible for the movement of each of these plates. As a result of these processes, as a result of nature of these processes, as a result of governing forces which are deriving the movement of a particular plate towards each other, towards other plate or away from other plate, generally the plate boundaries, it can be continent, it can be continent, ocean, or it can be ocean plates. So, two plates, whenever at the boundary, if you see, you can see a divergent plate boundary, means two plates are moving away from each other, as we can see in mid-oceanic ridge. So, as a result of divergent plate boundary, what will happen? The material, the material in the mantle comes up onto the surface, spreads onto the surface, and because these two plates are moving away from each other, so the new material comes onto the surface, gets settled on the boundary, and then the process of movement or divergent of this plate, this material will move. After some time, it will move away from the boundary, and new material will settle at that boundary. So, as a result of this continuous process, there will be continuous process of new landmass creation. This is called as divergent plate boundary. Then you can have convergent plate boundary. So, where the two plates are moving towards each other, or maybe the relative motion of one plate will be more than the other plate. That also governs, that is also governed by which plate is relatively softer, which is relatively harder, or which is relatively older or younger plate. That governs which process, which plate will undergo which plate. So, in this particular process, that is called as convergent plate boundary, the two plates are converging towards each other or moving towards each other. As a result, one plate will be going down or subducting, other plate will be above that plate. So, in this case, because the plate is moving under the other plate, the landmass is actually getting consumed. So, in the first one it was creating, here it is consuming different locations across the globe. If you see the plate boundaries, each of these processes will be happening at different locations. Now, there may be another condition where neither there is a consumption of land mass nor there is creation of new land mass. So, such plate boundaries are called as transform plate boundaries. Such boundaries generally exist whenever the rate of convergence is changing between two plate boundaries. So, you can have some kind of relative motion between those two convergent or divergent plate boundary having different rate of movement. So, this is called as transform plate boundary. This process we have to be very clearly understandable, like this process of divergent, convergent or transformation is a continuous process which is happening since the geological time scale, like we discussed about 66 million years of present configuration, and it has started as early as maybe 200 million years after that. So, this is a continuous process, as a result of which the above three types of plate boundaries people can it has been highlighted by geologists, even seismologists. So, along the continent and ocean plate boundary. Now, we are talking about initially we talk about onshore structures, the structure which are actually located on actual land mass. Now, we are talking about some structure which are on in the ocean. So, there is always a transition from continental land mass or continental boundary to oceanic plate boundary. So, along the ocean and continent boundary or interface, there will be gradual to sudden change. So, it can be gradual change, it can be sudden change in the topography. I am talking about the interface. So, there is a continent, there is ocean, and along between the two, the transition zone from oceanic plate to the continental plate to oceanic plate, there will be gradual to sudden change in the topography of the medium due to governing processes. One may be the plate movement, another may be because one plate, it may be at one location it might be subducting under other plate, but it might be other location at transform plate boundary, maybe with the oceanic plate. So, this is governing what kind of plate boundary, what kind of transition zone will be there, that is between the oceanic plate and the adjacent continental plate. So, it is generally governed by the processes happening at the plate boundaries and the layer thickness. As I mentioned here, sometimes the oceanic crust can be as high as 10 kilometer, continental crust can be as high as 80 kilometer and more than that. As a result of which, there will be gradual change in the medium characteristics of the continental plate and the oceanic plate also. So, this is also governing whether the topography will be changing suddenly or gradual change will be there in the topography of the medium. Now, important terminologies we discuss about, like oceanic plate is there, and every time whenever we see ocean, we always see in terms of mean sea level, which looks like more or less stable, unless you consider the effect of gravitational pull by moon or sun. But what is happening along beneath the earth, particularly along the ocean, we are going to see here. So, that give you better idea about oceanic floors. So, if you consider like this is your oceanic plate, then you are having this kind of then you can have something like this, like this. So, this is, I am referring to continent, this I am referring to ocean. Depending upon the extent of continental plate or oceanic plate, there will be always a margin. But what is happening here, if I mark here the mean sea level, there can be sea mounts, kind of partial to very high altitude deposition of sediments. Then you can have trenches here, which are possible. Critical example you can see maybe again with respect to mid oceanic ridge in the Pacific, you can refer to it here. Now, here you can see there is gradual change or gradual transition from oceanic this continental plate to ocean. So, this gradual change, it is called as continental shelf. I am just writing here the terminologies. Shelf, which is you can consider the submerged portion of continental plate. Now, there will be again ridge from where there is from gradual to sudden change in the belt or the topography of the medium. This is called as continental ridge. Then you are having again some again from this location till this location, again there is more or less same change in same rate of topographical change. So, this is called as continental slope. This I can give reference. Okay. So, this is continental slope. Again this is continental rise, from where again you are having change in the slope. Like till here it was steep change and then again it became gradual change. And then you can have axial plane, wherever it is more or less same, like very gradual change in the oceanic floor. This is called as abyssal plane. So, the range, the distance between continental rise and starting of continental shift, this location is known as continental margin. Like this gradual what I showed here, most of the time it will be like gradual transition from continental to submerged portion of the continent, at times very rare, it can have very sudden change also. So, this range is called as continental margin, considering portion of continental shelf and then continental slope. In between the continental shelf and continental slope there will be continental ridge, from where that the slope is changing from gradual to sudden. Now, why important it is? So again, so as you go away further from abyssal plain, you can have maybe some sea mounts also, you can have terrains also. So what important thing here to be understood is, like, though the mean sea level looks very normal or very leveled, but if you start exploring, because many of us while going through this course are not very much aware about offshore environment. So this is going to give you a clear idea about, like, though the mean sea level looks like very leveled one, but as you go deeper into the sea floor, there are a lot of topographical changes happening. It can be gradual, it can be steep, it can be again some kind of narrow but very significant change in the topography. Then it can be it can be below the surface also, it can be above the surface like sea mounts, it can be trenches, and so on and so forth. So as a result of which, you can understand that topography of the oceanic floor is also not remaining leveled, or it is not having uniform. So in addition to the change in the topographical features, even the subsurface material, like here I am talking about ocean or oceanic floor, whenever we go for any kind of offshore structure, we will be, depending upon the water depth, we will be going even for direct resting the structure on this, even anchored structure, we can go for even floating structure which will be anchored at the base, or we can go for like different kinds of foundation, different kind of anchorage, depending upon water depth, depending upon the purpose of the structures can be done. But what important here is, you can understand, like, the topography of the ocean can have different features. Again, if you talk about, so when we go for offshore investigation, we will be interested to explore offshore environment exploration. One important consideration which comes into picture when we go for any offshore investigation is, like, the ecology of the system. Like, wherever we are going to construct even like some kind of offshore structure here, during the construction, like before the construction, there must be some ecological system, there must be some aquatic life here. So during the construction, we have to ensure, particularly when we go for any kind of offshore investigation, offshore construction also, we have to ensure the effect to the ecology of the surrounding area will be minimal, and once the construction is over, it should be brought back to its original position or original condition, which was not there during onshore structures, that we are going to discuss in further detail. So this is like offshore foundation. Now, in order to ensure the safety of the foundation, very much similar to onshore structure, you have to explore what kind of soil is there. So seafloor subsoil, because the material characteristics are changing very gradually or sometimes very rapidly. Second thing, water depth is there. Third thing, you have to also take into account lot of process happening between the ground surface or water surface. Now this is like water surface, and you will be having some kind of vessels or ships which are responsible for exploration. So you are actually putting your exploration assembly here. At times you can actually do the exploration right from the ocean floor downwards itself. So both are possible, that we are going to discuss in coming lectures. As a result of this, vessels, it is going to explore first of all this medium, which is water depth. So lot of processes are happening along this, as a result of which there will be change in the wave velocity also, the water waves. As a result of which there will be change in the chemical characteristics of the water. There will be, again, with respect to depth, other constants also will come into picture, that we will be highlighting as we proceed further to this particular topic. But the common feature is like when we go for offshore investigation, like here we were interested in subsurface exploration here, but there was no ecological consideration in onshore. When we go for offshore, we have to take offshore ecological consideration. Moreover, the change in other characteristics will also govern the design consideration, will govern the or they will pose more and more challenges to your offshore investigations. So, we discussed about different topographical features or characteristics. So, one is like continental margin. It consists of continental shift plus continental slope. You can again refer back to the previous slide to understand this. Then you are having continental shelf, which you can understand as submerged portion of submerged but continuous portion of adjacent landmass. Adjacent landmass. So, because it is submerged, so it will be underwater, but it will be called as continental shelf. Then you can have the seaward extent of continental shelf, which is known as continental ridge or shelf break. Then you can have the toe of the shelf, toe of the continental slope is known as continental rise, leading to abyssal plain. Now, why? Because we all know, like nowadays we are seeing lot of other activities happening. Why we are going for offshore rather onshore, but primarily the objective why people started going onshore is particularly for oil and gas exploration. So, it has to be noted here, whatever we had discussed in the previous figure, it has to be highlighted here that the continental margin, that is starting from continental shelf to the end of the continental rise, the continental margin is an extremely important and most promising location for oil as well as gas exploration. So, whenever like based on particularly geological studies, even portion of seismological studies, people have identified the global locations of continental margin, where particularly the agency which are responsible for gas and oil exploration, they can go for detailed investigation, find out suitability of and the presence of those locations. So, more than another important thing is more than 20% of total ocean floor is consisting of continental margin. So, there are maps also, like one can refer to the maps generated by a United States Geological Survey, where you can get an idea about possible location of continental margin around each of the major continental plate, or and so on and so forth. So, this figure comes out to be 74 into 10 raised to the power 6 kilometer square of surface area. So, now based on this itself, you can get an idea like what is the extent of the area along the ocean floor on which one can go for exploration, particularly related to oil and gas exploration. Now, this is particularly I highlighted whenever we are going for offshore investigation. Why it is important? Particularly because you can get oil as well as gas in the oceans, for which people go for detailed investigation, and whenever they have to take out this particular gas and oil, they have to go for some kind of permanent structure there. To get that structure, they have to put some kind of foundation, either it is directly supporting the seafloor or it is anchored foundation. But in addition to this, there are other kind of structures which are also called as offshore structure and are used for different other purposes. So, when we come for offshore structures, these are generally classified as those structures which are built at specific location within sea, primarily for oil and gas exploration. This is like why people started exploring the sea floors, particularly for oil and gas exploration. But later stage, people have also used it as a support against lateral movement for transmission cables. Like we can see lot of transmission cables which are running across the sea floors. So, people I mean, in order to communicate, or in order to particularly during the World War II, also lot of transmission cables were laid along the sea floors. So, such cables, in order to avoid any kind of movement, particularly due to movement of sand dunes, maybe because of water currents. So, this cable should not keep on shifting from one location to other. You have to also provide some kind of lateral supports to these cables. So, these are again an additional kind of again to provide some sufficient mechanism against lateral movement, one should explore what kind of sea floor is available. Then third one, so the second one is another kind of objective for which detailed investigation one can go for to design the kind of supports. The third one is wind, as has been understood as a source of green energy. However, the erection of wind turbines, particularly in major land masses, first of all, land mass available for those locations, either because of geological constraints or maybe because of limited land mass available, it is very difficult in majority of the location to erect these kinds of wind turbines on actual land mass or onshore. But these can be, in comparison to actual land mass, erecting such kind of wind turbines will be significantly easier as well as more efficient in erecting these turbines into seas. So, another, for erection of wind turbines, you have to go for offshore structures, that is called as wind turbines, and in comparison to sea, the continuous flow of wind can be assured in sea. Then the most important thing which many of us can be observed in nowadays, like artificial islands. Classical example is like Palm Islands in Dubai, has been created for to promote tourism, also to locate human colonies also there. In addition to this, artificial islands are getting created as support ports in order to minimize the ship movement along the actual seashore. So, they can provide additional support ports within the sea. So, actual material which are getting transferred or import can be dropped there, and again from there it can be transported to the actual mainland through small ships. So, those are called as support ports. Then airports, many of the places we are seeing like people are creating artificial islands, and on that artificial island they are laying airports. Similarly, for heavy industrial purposes also, even for bridges also we can add here. Bridges nowadays, particularly like the Bandra-Worli Sea Link in Mumbai, then China recently opened another sea link which is quite lengthy. So, which were not practiced maybe 1 decade or prior to that, but are nowadays in practice. So, this is another classical application where one should go for offshore structures, and in order to erect a particular offshore structures, one should go for and one you can also add here tunnels, maybe like lot of places people are going for tunnels below the bed. So, once we are going for those kinds of structures, we have to go for proper investigation to ensure the safety of these things. Then seafloor are also used, are also found very feasible for long term storage of carbon dioxide. So, that also gives you another application. One should go for offshore structures, and once you are going for any kind of offshore structure, you have to go for proper investigation. Now, how offshore structures are different from onshore structures? Some of the ways include the clients which are requiring the offshore investigations are different than onshore investigation, and the governing authorities, as I mentioned here, the ecological the clearance from ecological governing agencies is must whenever we are going for any offshore investigation or any offshore erection of the structures. Then second, the offshore structures are significantly larger than many of the onshore structures. The design life of the structures are in the range of 25 to 50 years, which is different from the design life of onshore structures. Like most of the structures, particularly the oil rigs, are constructed, or even nowadays for the case of bridges, the most of the panels or parts of the actual structure are constructed onshore, brought to the actual site and are assembled, which is not done particularly in case of onshore. Then next one is ground improvement. Whenever we are requiring any kind of ground improvement, most of the time it is not possible, and if it is possible, it will be very expensive, because the environment in which you have to do ground improvement possess lots of challenges to the actual execution of the work. Then lateral loads, either because of the winds or maybe because of water currents, are significantly higher than in comparison to offshore structures, in comparison to onshore structure. Then exposed to large range of geohazard. Any offshore structure will be like tsunamis there, then water currents are there. Even whenever we are going for colder environments like northern glacier, most of the time in addition to water current there will be impact through ice or glaciers. That is another thing. Then tsunami, as I mentioned, then earthquake is also there. So, exposed to large amount of geohazards. Then ecological consideration should be given due importance, or are considered to be most important here, because of which, though every location, the location which are of continental margin, but not everywhere people are going for exploration because of these restrictions. Then cyclic loadings are very dominating in comparison to onshore structures. Modifications, as I mentioned particularly during the module 1, like when we go for onshore structure based subsurface exploration, it is like one is for choosing the particular foundation, and as well as in case you find any difficulty during laying the foundation, you can think of alternate structures or alternate option, but that modification particularly in case of offshore structure will be very difficult. Then in case there is a failure in offshore structure, you will have huge penalty in terms of finance as well as in terms of environmental impact. So, in order to get clearance, first of all it is difficult, and in case there is failure, so there is the agency, the factors on which the impact will be there, it will be significantly higher. Now, we mentioned about geohazards. So, hazards which are responsible for the loss of life and finance and are particularly associated with geology as well as geotechnical characteristics of the particular site or its environment or its vicinity can be classified under geohazards. Such hazards can compromise the serviceability of the structure, its foundation during its design life. So, that is why geohazard should be given proper consideration. For the safety of any structure, again geohazard, we generally take into account what is the likelihood of any particular geohazard. It can be because of tsunami, it can be because of earthquake, it can be because of water currents also. So, what is the likelihood for that particular geohazard to affect the structure, and then accordingly the above factor should be given due importance in the design consideration and should be explored properly during exploration. To give you an example, like probable earthquake scenario and its associated ground motion, what will be the ground motion which is induced at the structure level or maybe at the base of foundation and ocean floor interface. So, that should be given due importance here as a part of geohazard. Now, seafloor consideration. So, this is very important here. Though the seafloor at majority of the locations are flat, the trenches and seamount which I told you, those are available at specific locations, but not throughout. So, most of the time you find seafloors are very flat. However, there will be significant variation in the subsoil characteristics available at the seafloor. So, it will be varying along the depth also, it will be varying laterally also. In addition, if there is a presence of fault which is identified particularly when you are exploring very larger area along the alignment of gas or oil pipeline laying or maybe transmission line cables laying, you have to also explore seafloor. What are the possible faults which are coming along the alignment, what are the possible movement there, so that your mechanism for anchorage should be designed properly, that so that it can withstand that particular movement without compromising or without endangering the safety of the structure. Then chemical characteristics of the water keeps on changing with respect to depth also. So, what will the impact of that change in the chemical characteristics upon the strength characteristics of the soil, because you are going to explore, you are going to investigate the soil, but how that soil characteristics is getting compromised with respect to the its environmental condition or chemical characteristics of water, that you have to understand. Secondly, the impact of these chemical characteristics upon the foundation material. The most important, as I am highlighting again and again, the flora and fauna of the proposed site and its vicinity, which are going to get affected by the construction activity as well as the presence of that particular structure, has to be given proper importance. Now, sea bed material, like we are discussing, like it is changing, but there are important considerations which has to be taken into which should be given proper importance here, include like the unconsolidated sediment which are often possibly available at the seafloor. So, unconsolidated sediment means those are not given proper time even to complete the primary consolidation. So, such sediments will be softer in material, softer in nature in comparison to the denser material. So, that characteristic has to be understood while addressing the strength characteristic of the material. Calcium carbonate, material which easily gets dissolved in water and precipitates and form calcite, which is available in abundance along the sea floor, particularly because of shells and other things. So, once the organism dies, even that time also it get precipitated and form calcite. This calcite binds the softer material or even harder material together, but depending upon the characteristic of the calcite itself, the binding characteristics of the end product will vary. So, that has to be given due importance. Third thing, first one is like the settlement behavior, the consolidation behavior of medium. Second thing is the binding characteristic of the calcite. Third thing is shallow gases which are present in form of small bubbles in pore fluid, either within the soil pores or in terms of gas nitrates in the solid layers. So, once you start drilling, what happen at times, these bubbles comes out so quickly, it can even lead to explosion in the drilling assembly. So, one is drilling assembly, and second thing, these gases, these nitrate gases, these are very poisonous, and it can also cause some kind of accident, or it can cause even death also to the handling people. So, we have to be very extra careful considering explosion point of view or considering the casualty point of view. So, in order to avoid any accident, whenever we are exploring, whenever we are going for any kind of detailed investigation in those locations, so those are called as SAR gas fields, we have to be more careful, and we have to be, either we can avoid, but majority of the location, if we cannot avoid, we have to be prepared for that. So, to handle that situation properly. Sand dunes, as we know, like there will be sand dunes which keeps on shifting because of erosion happening at other location, removing the material, and deposition happening on other side of the sand dunes. So, if this process keeps on happening, the sand dunes keeps on shifting, maybe slowly or maybe quickly, depending upon the rate of erosion or as well as the rate of deposition. But what happens if these sand dunes come above a particular existing foundation, either they will bury the foundation, or if the sand dunes are significantly heavier, it can induce a settlement to the existing foundation, and thus can compromise the safety of structures also at times. Then another thing, like the presence of bed. If the bed is harder, sometimes it gives you a challenge in going for pile foundation, because it offers more and more resistance toward driving. Another complication, when you are going for hard bed, it offers very limited resistance to as skin friction or shaft resistance. So, in comparison to hard bed, tough beds are generally preferred, and if it is not possible, then you can go for maybe a suitable kind of pile foundation material. Today's class was more about how the ocean floors came into picture, particularly referring to continental drift theory, then what is happening at the interface, then why people started realizing why the exploration of sea beds are important. When we go for sea beds, it is not very leveled one. Sometimes you have very much undulation, sometimes you have trenches, sometimes you have other characteristics. So, the topographical features are varying significantly. Then along the transition boundary, you have where there are possibly higher chances of gas and oil storage, people started exploring. And then coming over to the recent demands, when people are going for artificial islands, wind turbines, bridges, tunnels, and storages for carbon dioxide, more and more applications of offshore structures are coming into picture, which also alarms whenever we are going for any kind of offshore structure. As I mentioned earlier, we have to go for detailed investigation, so that so as to ensure the safety of the structure during the design life, as well as with minimal disturbance or almost no disturbance to the flora and fauna or ecology of the system, so that the structure can be built as such into the proposed site, as well as it has minimal impact or no impact to its surrounding areas. So, thank you so much. In the coming slides, in the coming classes, we will be discussing these things in more details, how the exploration programs can be planned, and typical examples of different exploration techniques. Thank you so much.